Okay, so we are going to solve this question. It is a vectors number. We are being required to first of all find the following vectors in terms of P and R. What is P and R? According to the question, P and R have been given pretty well. Vector P is OP, which is from here to there, OP. Then we have vector R, which is OR. If you to look here, OR is right there. So we are supposed to find SP, OK, PK, then show that PK is R collinear. It's pretty easy and quite straightforward. So we'll get started with the workings. So we are going to straight away start answering this question. Now, besides finding OP, knowing that OP is that, OR is that, we have some extra information here that we need to factor into our diagram. For example, here we have OR to RS is 1 to 1. So when you come here and you look at the diagram, and they're talking about O to R, then R to S, the ratio is 1 to 1. What does that mean? If it means it is 1 to 1, it means that point R is in the midpoint of OS. So that is how that plays out. Then we have OP to OQ is 2 to 3. So we have O to P, then we have O to Q. The ratio is 2 to 3. How do we interpret this on our diagram? Well, it's supposed to come out like this. So OP is 2 parts. So it means from here, O to point P is ratio 2. Then OQ is 3 parts. So it means for me to move from O to Q is 3 parts. So it means that if OP is 2 parts, then OQ is 3 parts. So if this is 2, it means that this remaining part is, 2 plus 1 to make the 3. So in other words, the ratio from here to here is 2. If I was to say OP to PQ would be 2 to 1. So I think you've been you've closely monitored how I have interpreted this ratio. I'm following the letters from where it's starting to where it's ending, and I am following the ratios. OP is 2, OQ, that is from here to there, OQ is 3, and so it means that 3 minus 2 gives us 1 here for this remaining portion. So I label it like that because I'm definitely going to need this to guide me in my interpretation of the questions that I'm going to do. Then we have 2QK is equal to QR. So we have QK right here. So we have QK, then QR. Then we also have 2QR like that. However, this one is not in ratio form. Like, it's not been presented like these ones, the way how they have been presented. It's been presented like this. So what we do here, for these ones, I'll do that right here. It is 2QK is equal to QR. So again, this QR, there's an invisible one here. So we put the letters on both sides. For example, here I'll divide both sides by QR, so that this goes with that. So this means it's going to become 2QK over QR is equal to 1. I'll remove these 2 from here, divide by 2 here, divide by 2, so that these 2 and that 2 go. So we have QK over QR being equal to 1 over 2. This is the same as saying QK to QR is equal to 1 to 2. It's equivalent to doing it like that. So after demystifying it like that, so when you come to QK, you say QK has ratio 1. So you come here and say QK has ratio 1. And then we have QR has ratio 2. So from Q to R, meaning the first one was QK, which was ratio 1. Then from Q to R, according to what we have here, QR is 2. So from Q to R is 2. So meaning that if this is 2, 2 minus 1 gives us the remaining portion of KR as also 1. So it means that this and that is also 1 to 1. The total ratio is 2, just like that we did here. So with that, then let's proceed and start doing our question. So they want us to find SP. So Roman 1, SP. First of all, SP, we can take any root. We can say, for me to move from S to P, I can say SR plus RK plus KP, or I can say SR plus RQ plus QP, or I can say SO plus OP. Let me take the shorter one. For me to do SP, it is SO plus OP. So I'll come in here and say it's SO plus OP. So that is going to be equal to what is SO. For me to move from S to O, you realize that this vector R right here, you're seeing, according to our question, we are being told that OR is vector R. However, this R only stops from O to R. It does not stretch up to here. But also, we need to put our answers in terms of P and R. But then let's look at our question closely. In our question, we were told that OR to RS has a ratio of 1 to 1. And if you look at this, OR to RS has a ratio of 1 to 1. What this means is that the distance from O to R is the same distance from R to S, because R is the midpoint. So if the distance from O to R is the same as the distance from R to S, it means that if this is OR, according to the question, is R, it means that RS here is also R. That is what this ratio of 1 to 1 means. It means that this portion is the same as that portion. So it means, coming back to our question here, to find SO, to move from S to O, it means you're moving in the opposite direction of negative R, negative R. So in other words, SO is negative 2R, then plus OP. For me to move from O to P, that one is called P, and that's right there. So that's the answer. Maybe you can just say P minus 2R. That's the answer. That is SP. Or you can also leave it at this level and just double underline it, still the same. It's okay. So let's go to Roman 2. That was SP right there. Let's go to vector OK. So to find vector OK, our O is here and our K is right there, and we need to get to there. So either I can move from OP plus PK, or I can move from OS to SK. Either way, I get to the destination that I want. Our OK. So for me to move from O to K, let me use this root. So I'll move from OS plus SK. So I'll come here and say OK, it is OS plus SK. So what is my value of OS? OS is R plus R. So for me to move from O to S is 2R. So this is 2R positive because it's in that direction. Then SK. According to our question, we do not have anything on SK. We do not know what it is. So you realize that for me to move from S to K, we are having a problem. This S to K is supposed to be probably a certain scalar of SP. However, according to our question here, if we look at our information, the information that has been given to us in the question, there seems to be no information about SK. There seems to be no ratios connecting this line. So this means using this root would become a bit problematic. So maybe I should probably change and ignore using this root because it is not labeled anywhere. Since my question, we are telling us they want OK, let me travel through the roots that have known ratios, because those ones are easy to figure out. So I had used from O to S, then S to K, but now I'll change. I'll say OR plus RK. So I'll make this, I'll change this because this SK is a problem. It's not labeled anywhere in our question. So let's change the root. So I'll cancel this and I'll say our Roman 2 is OK is given by O. I'm going to move from O to R. So I'll call this OR plus, then I'll move from R to K. So I'll come here and write plus RK. As long as the first letter is O, and the last letter is K right there. The things in the middle are supposed to just be continuous. So what is OR? According to here, OR is vector R plus what is RK. For me to move from RK, it is labeled here. It is in the ratio of 1 to 1. So it means that it is 1 over 2 of RQ. So it is here, it's going to be a half, because that's the portion here. RK is a half of this whole line, RQ. So we are getting that information from the ratio, because this is 1, this is ratio 1, and the whole bit is 2. We got this from our information at the beginning of the question. So RK is a half 1 over 2 of RQ. So it is 1 over 2 of RQ. So the issue is now what is RQ. So our next level is going to be R plus a half RQ. So RQ is actually, we remember we are doing this, we want to make sure that our answers only have P and R. So we have RQ in terms of P and R, we use this root because they're the ones that are labeled. So it's going to become RO plus OQ. So we shall come right here and say it's going to be RO plus OQ. So that's going to become R plus a half into RO. So right here we have RO here as negative R. So RO is negative R plus OQ. OQ. Now you realize, according to our question, we only have P labeled from here to there, right there. So the OP only covers OP, just this portion, but PQ is blank. It is not at all labeled in terms of R and P. However, we know that the ratio, the total ratio here from here to there is 3, and we know that this P is in 2 parts, it's occupying 2 parts, and this other portion is only occupying 1 part. So it means that if this is ratio of 2 to 1, if P occupies 2 parts, it means this 1 part is going to occupy half of P. So in other words, for me to move from O to P, it's going to be P plus half P. So I'll come here and say it is plus P plus a half P, and definitely that is going to be, with the rest is now just rearranging things, so it becomes R minus a half R. P plus a half P is 3 over 2 P. So this is 1 minus a half gives us a half R plus 3 over 2 P, and that is the answer for OK. Now, for those of you that are still confused on how I got a half, let me do some small working on the side here. O to P is P, and that P is equivalent to 2 parts. So if P is equivalent to 2 parts, what about PQ? If PQ is equivalent to 1 part, we want to find PQ now. When we cross multiply this times that, becomes 2PQ is equal to this times that, which is P. So it means when you divide both sides by 2, you shall end up with PQ as a half P. And that's how we got it to a half P right there. So this right here is our answer. So let's go on to Roman 3. Roman 3, where we require to find PK. So it means I'm supposed to find the distance from P to K. So for me to find the distance from P to K, I can use PQ plus QK, or I can use PO plus OR plus RK. So let's go ahead and find PK. I'll use the shorter route, PQ plus QK. So that's going to become, and that's going to be PQ. PQ is a half P plus QK. QK is a half of QR. So this is a half of QR. So what is that going to amount to? What is QR? QR is QO plus OR. So this is going to become a half P plus a half into QR. QR is QO. Now QO is negative 3 over 2P. So it is negative 3 over 2P plus OR, which is R. And the rest is just adding. So it's a half P So the question continues to tell us to go on and show that P, K, and S are collinear. Now from here, P, K, and S, we have P, K, and S. We're supposed to show that these two are collinear. Of course, to show that P, K, and S are collinear, it's supposed to be like this. We know that for P, K, and S, these, to show that they are collinear, they are supposed to be PK should be equal to a certain scalar multiplied by Ks. So we're going to go ahead and find Pk, then find Ks, and then find the value of a scalar K, the multiple of this. So what is Pk? Pk, we already got Pk from here. Pk is already this. So in other words, this is going to be negative a quarter P plus a half R. This is going to be equal to K times Ks, the scalar K times Ks. Now what is Ks? Did we get Ks? We didn't get Ks at all, but we know that Ks is also Kr plus Rs. So we can find Ks. So Kr plus Rs. So let's try and find Ks. So this is going to become K outside the brackets into what is Kr. If I come to my diagram, Kr is a half of Qr. So Kr is a half of Qr plus Rs. If you come here, Rs is R. So Rs is R. So we already, can we get QR? This is going to become K into a half times QR. Now we already got QR in our previous question. We were looking at QR, we got it as this expression. So we're just going to go and copy that expression down here. So QR is negative 3 over 2P plus R. That is the QR. We've just put there then plus R. That is equal to the remaining bit here, which is negative a quarter plus a half R. So we're just going to go ahead and simplify this and make sure we find the value of K. Factorizing this out is going to give us K into, we factorize this out, remove 3 over 2 outside the brackets. We put 3 over 2 outside the brackets here. Into 3 over 2 divided that here, we only remain with R. Then that is minus 1 over 2 P. So realize that in the brackets here we have R minus 1 over 2. Even here we have R minus 1 over 2P. So this R minus 1 over 2 and that R minus 1 over 2P, they cancel out. So here what we remain with is a half is equal to K times 3 over 2. And our value of K here will be equal to a half times 2/3. This goes with that. Our value of K here is 1 over 3. And so we shall conclude by saying that since I'm ready.